Let's wait. Okay, hi everyone. Let's start our uh, session studying the book Quarks in Action. And today, let's talk about the fourth chapter, chapter 4, where you see about the communication between microservices, synchronous communication, gRPC, GraphQL, and HTTP. Thanks, John Cimento and Victor, to stay here with us today. And feel free to ask some question for Martin. And okay, I think you can start, Martin. Go ahead. And thanks again for
Sure.
this this session.
So, okay. Host the disabled attendee screen sharing. So you need to allow me to share if I want to show something. What else?
Can we repeat, please? Sorry.
You as a host, you disabled sharing for attendees. So you either need to make me a co-host or allow me to share the screen because I
Yeah.
will not
Okay.
be sure.
Sorry. Okay. I will make you as co-host. And Dennis, Frederick, uh, welcome to our
So
book club.
now you should be able to see my screen.
Yeah.
And you should see the book. Perfect. So we can start. So as Matteo said, today we have a lot to cover. So this is the first session where I will be not live coding everything because it's not humanly possible to type everything in 1 hour. Today we are going to focus on the synchronous communication protocols that are most popular in Quarkus, and that's REST, GraphQL, and gRPC. We will go through all of them already on top of our example application, which is this. Oopsie, Daisy, what did I do? Which is our car rental application, which you will probably need to bake into your memory because for the rest of the book, minus last chapter, we are going to basically develop this system. Uh, as you can see, this synchronous communication. No, you said synchronous communication. You said it correctly. Uh, the rest is used to communicate here and here. Probably in this chapter 4, we are going to only implement this one, GraphQL here and gRPC here. So as you can see, today we are going to already create first 3 of our 5 services plus the inventory CLI, reservation, rental, and inventory. And this is what we are going to look at today. Just because this is really too much to type, I will be looking at the book code which you have available on GitHub at xstefan/Quarkus in action, and Mateus can probably send it to the chat. Thank you. So we are now at chapter 4. If you go into the chapter 4, everything that we will be talking about, all the code that is being typed is versioned or it's separated into a separate directory. So you can see here that we are in 4.2 creating reservation service. Then we are doing something in the reservation service. In 4.3 we are adding another service. So it's already only 4.3. But what is important is that wherever you will be reading the book, I just want to remind you, let's say that you are at section 4.8.1, you have this link right next to the directory, which will directly show you the diff for that section or whatever is implemented in that section. So I will be using that a lot. If you are surprised by the colors that I am having on my GitHub, that's because I'm partially colorblind. So blue is additions and this whatever is deletions. So just like that you are not surprised. Okay, let's dive right in. So our system, this car rental, consists of 5 services. Just that you will understand, because we will be calling this a lot. Our front-end users is 8080, reservation 1, rental 2, inventory 3, and billing 4. Today we are going to create this 3. Users we will add in chapter 6, if I remember correctly, and billing only in chapter 9, I believe, because billing will be fully reactive service. Okay, so reservation service, I am going to skip through most of the stuff, and I will probably implement something on the side if we have any questions. So please feel free to interrupt as much as you want. Like, we can always try something on the side or try it inside this project, because everything is version, so I can jump around as much as I like. Okay, so I am now inside that GitHub repository in my terminal, and I can open, let's say, 4.3, because we want to be by the end, and let's open reservation service in IDEA. Because the first thing, okay, sorry about that, I don't have IDEA running, so I need to first run IDEA, then I can do stuff magically. I need to just open some project. Now this should work, and it does. Come on, idea, be fast. So I suppose that most of you already seen a normal HTTP expose server in Java, at least in one API or another. Most likely, for those of you who are coming from Spring, you will have just the issue of understanding what kind of annotations you need to put on your methods or your classes, but more or less is exactly same thing. And I will not really jump here to explain all the mappings, because that's kind of impossible. What I will recommend is this Quarkus for Spring Developers PDF, because I don't remember the URL, which is this free ebook, and I will send it to the chat, which you can download on Red Hat Developers, which is 200 something pages small, where all of these mappings are in one place. So you can like check, if you are a Spring developer, how to do it in Java EE way in the specification, which we call the JAXA REST or Jakarta REST now. And this is what I'm going to show you today. We can run it in dev mode, so we can actually try to play with it a little bit. And here, REST reservation networks. So in JAXA REST way or Java EE way, we define our REST resources or HTTP resources by this path annotation from Jakarta VSRS package, which takes the root path on which this particular resource class is exposed. So whatever my server is running on, in my case, it will be localhost 8081 / reservation is this reservation resource. Then we can skip like this part. Individual methods need to be annotated with one of these HTTP method type annotations, which are either at get, at post, at put, at options, etc. Like all of these HTTP methods has the representation in these annotations. And then optionally, you can also add path annotation. This is exactly the same annotation, but if you don't add it, this post method would be exposed directly at HTTP post / reservation, but this add get method would be, the idea is actually helping me, and it's written here. I didn't notice that. Will be exposed at localhost 8081 / reservation from the class / availability from the method. And you can also write slashes inside here if you would like to. So this could be something else, blah, 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 whatever you like. So now if I will check my application running on 8081 / reservation / availability, too late for me. We are getting already some data back from our service, so it's working like this. If I would change this to whatever, search, now I can call it on search. Nothing fancy, and I hope that I don't need to now explain dev mode. We already saw that, so you know that if I'm running in dev mode, it automatically restarts in the background when I call it with HTTP. So this would be more or less the basics. Then you have a bunch of annotations which will basically work with your services, like this consumes, for instance, define the accept header, which is used for this method. So if I would like to make, oh my god, the call to this particular method, you see that it's taking a parameter, which is a method body, which I need to, or method body, HTTP request body that I'm sending, which in my case will be JSON. So I'm specifying that basically accept header for this, or content type header for this request from the client side needs to be application/JSON. Nothing fancy. Just probably something worth mentioning is that when you are using Quarkus REST extension, which I forgot to mention, this Quarkus REST comes also as a plain Quarkus REST like this. Just this plain Quarkus REST extension is only exposing the server. In this application, we are using -JSON because we also want a JSON mapper, so we automatically can transfer the JSON objects or JSON strings, which are passed to our service, to map to our Java classes. And all of this magic is just done by this -JSON. If you add this -JSON on your class path, out of the box, all methods which are returning or consuming objects are automatically considered producing or consuming JSONs. So this is kind of redundant. It's only there to showcase what we are doing. But as you can see here, collection car, I don't have that consume annotation or produces annotation, which would be the accept header, but the REST JSON extension already knows that I want to return JSON, and it parses it as application JSON content type, as you can see here. Oh, what did I want? So this is how you would define the server. Also, you can define query parameters, path parameters, etc. There is a bunch of stuff that you can define. Here we have only the example of the REST query. So I can optionally specify here availability somehow question mark and I will not be typing it because it's too long, so I will help myself with the book, right? Here we have more or less written everything that I'm talking about. You can see here the availability method, which I was just showing you now, and somewhere here I should hopefully see an example. I don't have the example here, but at least I can see like what I need to write, so I can try to write it. Start date, what is today? 2025 09 24, and end date 25/09/25. Yeah, so it works. So this is how I will pass basically the query parameters with this REST query annotation. And there is also REST path, etc. But I am lying you a little bit because this REST query is actually coming from our classes, from our REST implementation, but there is also some annotation, which I think is just add query in JAX-RS, which is doing exactly the same thing. So if you want to stick to the specification, there is still this option, just this is more pleasant to write. And you can see that it's automatically parsing, for instance, the date that I'm passing to the method as local date, which is extremely useful. So feel free to ask any questions, but like it's really, there is no point into going into like overall possibilities that you can implement with this. From now on, I will just really be, like scratching the surface because we need to like showcase that it's possible. But like for the individual use cases, Quarkus documentation, or in this particular case, also the JAX-RS specification, you will get all the information, and that's probably reading for like 2 to 3 days. So like there is a lot of stuff that you can do here. So REST, okay, interesting. REST is by itself definitely still the most used protocol that you will run into in your like normal application work. Well, it's still probably also the to-go way in Quarkus, because if I will generate, let's do here a new Quarkus applications, Quarkus create app io func test app, you will see that if I don't specify any extension, somewhere here, I am by default getting the REST extension out of the box. So if I go into my test app and run just Quarkus extension to list the extension in my application, Quarkus REST is actually the default that we want to include, because it's the easiest way how to expose your application. So many developers won't know how to call HTTP with curl and etc. So it's still the to-go protocol for most people. If you want to call your application from the other side, so you need something which is called REST client. In this section, we also start creating rental service. This is why I went to rental service, because I wanted to have it open. So I will open it next to it. And I need also to open the reservation service, which I very stupidly closed. So now I will be running 2 dev modes on my local machine, and it's a little bit slow because probably I'm streaming and my resources are running out somewhere. But now I am running my reservation service on port 8081 and my REST client rental service on port 8082. So now if we check the client code, how we can define the clients. Rental also defines HTTP server, which is only having a single post method exposed at /rental/start/user ID/reservation ID. And you see that this is having different colors because it's in these curly brackets. And that's because we are actually defining this as implicit path parameters. So you see that my start method here is taking user ID, which is directly mapped to this user ID just because it's having the same name. If it wouldn't have the same name, I need to change it with the path param annotation, if I remember correctly. But for now, we are good as it is because the name matches. And this is how we defaultly look for the individual parameters. So if I want to make now an outgoing call to check something from the rental service to the reservation, I need something which is called REST client. REST client is another extension in our Quarkus application. So here we have Quarkus REST JSON that we already know, but we should, and we don't, because I am in the wrong chapter. So at least you see like how easy is it to get lost in your own book. Because in this for.free section, we still don't implement the REST client, which is only implemented in, let me check. So for.free is REST client, but we are implementing REST client in for.free. So where is it? No, inventory service, REST client, reservation. So it should be there. Why is it not in for.free? Now you will see a very interesting application of mine, which is just doing diff on, oh, I know why. Sorry, I am just lost now in what, oh, it should be here. So let me check GitHub. GitHub knows the best. So using REST client should be actually implementing rental client. Oh my God, because I'm stupid. That, okay. I will find what I'm doing eventually. It's just a long day for me. So let me start the reservation service again and start the rental service again, because I forgot that we are calling rental from reservation. So we have the REST client in the reservation. So this is why I wasn't able to find it in the rental, but here back in reservation service, you can see it somewhere here. We should have, and we have this Quarkus REST client extension. So you see that it's exactly the same as Quarkus REST. We are just adding that client. It also comes with this JSON, and also something which I forgot to mention, there are alternative different even JSON mapping frameworks. So if you want to stick to a specification space, there is also JSON-P or JSON-B mapper, which you can use in exactly the same way. So basically, you are free to choose whatever you need in particular application for different use cases. Also, without this add JSON, it would still work. This JSON is really just adding that automatic parsing to JSON and back to my JSON object, so I prefer to use it. When you want to basically map any JSON either out or with the client, you need to model the structure of the JSON like this. You basically create a POJO with your individual fields mapped to properties in your JSON and just getters and setters. So that's pretty easy. But the individual REST client needs to be defined as this, as an interface annotated with this register REST client annotation that can optionally take this base URI link, which you can see is pointing to my rental service already. But then you are using exactly the same annotations to define outgoing calls as you are doing it for your own server. So you can see that I have the same at path, again, the same at path, at post, REST path, etc. This is one-to-one mapped. Basically, I can copy paste this rental resource from which I am calling to an interface on my calling side, and I have a REST client. This is what we called declarative REST client, and this is defined by another specification, which is called microprofile REST client, which is in the microprofile project or specifications, which we talked about before. And basically, there is also a way how to create clients in JAX-RS, but it's more programmatic and you need to define everything yourself. With Quarkus, you have this option to define it with REST client, which is, in my personal opinion, way nicer. So now, if I will call this start method on any bean from which is defined as rental client, Quarkus will automatically generate the actual client implementation in the background, and it will make the HTTP call to the rental service. Go ahead, Victor. I cannot hear you. Yeah, probably.
Are you talking, Victor, or can you type the chat or?
Too much mutes.
No problem.
You hear me?
Yeah.
Yeah.
We can hear you.
Sorry, guys. So Martin, I was talking. If I have some configuration, additional configuration for the REST client, for example, the authorization bearer token, how can I define this in this situation?
Actually, we are using that. I think in chapter 6, there is an annotation for that. So you can also define headers in this with header param, if I remember correctly. So we will actually be seeing this in chapter 6, like how to propagate the token. Because we are actually going to use that from the user service to propagate to reservation, etc., to get the user ID. So, definitely everything is possible. Everything that you can do in HTTP is mappable in JAX-RS and this REST client. If there is something missing, they have to edit. Basically, this needs to be fully compatible with HTTP.
Okay, got it. And yeah, by default, I think the REST responses is blocking or non-blocking, right? Could you just quickly talk about this?
That is a tricky question, but very good question. Well, how to put it? You are partially correct that everything is non-blocking in the background, but it depends. If you will return direct type, direct pojo, then it will definitely be blocking from your perspective. So you don't see the actual call in the background. But now we are running ahead of ourselves. But we will get to this in, I don't remember, chapter 8 or somewhere like this. I will be showing you the reactive APIs. So if I just make this single change, I will, instead of rental, I will return uni of rental, which is an asynchronous type coming from project called Small Mutiny, which is really async promise. Either you have a result or you have an error. Quarkus will generate a reactive client in the background, and this will be non-blocking.
Okay.
But like even in that first case, if I am using, because if you are using Quarkus REST, let me just clean this out. Quarkus REST, this Quarkus REST client or Quarkus REST Jackson, this is in the background using project which we now call Quarkus REST, but in like before 3.9, it was called REST Easy Reactive.
Okay.
Because we basically re-implemented the whole REST layer on top of this small Mutiny and Vertex. So you are actually using non-blocking client in the background, but as I was saying on some session before, going from reactive call to blocking is just that block or that get. Going the other way around, it's not really possible. So you are still using asynchronous client, just if you defined it with direct type, you are not having access to asynchronous result before it is returned.
Okay. Got it.
But
Thanks.
But just changing it to uni and you are good to go. This is just possible because of that. But there is also Quarkus REST Easy. I'm not sure if Jackson, but it should be Quarkus REST Easy Jackson, which is actual project REST Easy from Wi-Fi, which is blocking REST client in the background. This is our back in Red Hat, it was our only implementation of HTTP server and client, but then in Quarkus we decided to re-implement it from scratch because we have Vertex client in the background, which is non-blocking. So very good question.
Okay, thank you.
Okay, just let me fix this back because I don't want to make changes. So if I now call this method, as I was saying, this will make an HTTP call to my rental service. And if I check, so we already saw this, but I wasn't pointing it. Here you can see that I am having this rental client, which we defined with this register REST client annotation, as I was saying. This base URI is just hard coding some URL, which is very great for testing. But later, even in the book, we will be showing you how to externalize this configuration to basically normal application config. And now I see another question in the chat. How do you set timeouts, read timeouts, etc.? Oh, that's actually a good question. I don't remember on top of my head how you will set timeouts. There is definitely another specification called microprofile fault tolerance, which is like providing you with annotation timeout. And I think that this is the way how we recommend how to do that. So go ahead.
Sorry, I will share the documentation at the point that talk about the connect timeout. Okay.
So there is also a timeout way. Yeah, you need to
You can configure it
understand
configuration
having
properties.
having everything in your head is impossible. Like we are talking like in general in Quarkus you have now like 850 extensions. So like there is no single person that is having like everything in their head. But you can read it in documentation for sure. So just coming back, because like I don't think that we can cover like all three today if we are going in this, because we are already halfway through and we are still at rest. Or either I will take it very fast, or we will need to have a separate session, but let me try. So my rental client is an interface. If I want to use it, all I need to do is inject it into my application with this REST client qualifier, which is coming, as you can see, from microprofile REST client. This is normal constructor injection. I can also write this if you prefer field injection, like inject REST client like this. Just it's for some use cases, this is more preferable, especially when you're doing testing, etc. So this is normally injected instance of that interface, which is really in the background will be basically generated implementation that Quarkus REST client library will generate. So it's basically all you then need to do is call your start method. And if you will call your start method, this will be translated to real HTTP call to hard-coded HTTP localhost 8082/rental/start, blah, 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 blah. So if I would make the reservation, but unfortunately I didn't prepare to make a reservation, so I hope to find it somewhere here in the book, because we should have the example, I hope, but we don't. We don't, because we are telling you to use Swagger UI. So, okay, let me try to show you Swagger UI. So, you remember that if I press D, I will open the Swagger UI, which I opened, of course, in wrong browser. So I need to do a magic here and do now D here. Somewhere here, I should see my REST, and I don't have, yeah, here I see Swagger Open API. So in reservation service, I have also included this small open API extension, which just will generate the open API document from my application, my HTTP interface. And if you have that, then it will basically give you this integrated Swagger UI in the dev UI itself. So now I can actually do post on reservation without actually remembering how to create the JSON, which is extremely great. So if I now will execute it, we should get a curl into our application, and we should see that something happened. And if we are not listing the reservations, but if I do availability for the same dates which are there, I should not see my single car. Yeah, let's not like go into this too much. You can see that it is working, it is calling my application, but I don't remember the exact details which I need to pass. So you will excuse me that like I will not showcase this in like a reel, but inside the book we should see that it basically, if you will create a reservation for a particular date for a particular car, and then you will ask for the availability for the same dates or subset of that dates, then that car should be missing from the list, of course, because it's already reserved for your created reservation. But yeah, let's skip this, because then we would be here till the end of time. And what we basically can do now is that in our service reservation resource, if the start days is today, we are actually going to call our rental and directly start the rental. So if I will, where is it? Try to change the parameters here. So let's do ID1, car ID will be 0, and today is 25/9/24. And this needs to be just after, because it will fail somewhere else. And if I execute this now, response still 200, but we should see in the rental service that we are starting rental for user X, it doesn't matter, with reservation 2, which is exactly our reservation that we created somewhere here, ID2. So you see that I am like really propagating the code through the REST client. Okay, nothing fancy. I think everybody understands this. So let's move now to GraphQL. Really, we can like come back to HTTP, and we will be coming to HTTP a lot throughout the book. So I think that we can park it here. Okay, HTTP. Oh, sorry, GraphQL. GraphQL is an alternative framework originally developed by Facebook, if I remember correctly, which will basically remove the limitation of HTTP or a REST framework by basically allowing you to specify individual fields that you as a client you are interested in. So it solves the problems of so-called overfetching and underfetching. Overfetching is when you basically are interested only in, let's say, two fields. You just want start date and end date from the reservation, but with our current solution, you will also get the ID and car ID. So you cannot really just get these two fields. You always need to propagate the full JSON object. And especially when this JSON is big, that can be potentially a lot of network traffic and a lot of processing, which is kind of unnecessary. Underfetching, on the other hand, is a problem when you need to do multiple REST client calls to your server to get all the data that you need. And this is what GraphQL aims to solve. So with GraphQL, you will define basically model in very similar way how you would with REST interfaces. Just then, when you are actually defining, and something which I should mention, now we are creating third service called inventory service, which will be our main like inventory tracking service. Then basically, yeah, this is just some initial data. I want you to look here. Then you will create your GraphQL server API in a very similar way as HTTP. You will just define it with GraphQL API annotation. And then you need to basically annotate the methods with either query, mutation, and I think that's it. There is also streaming in GraphQL, but I think this is done automatically by just returning some asynchronous type that I don't want to mention, but it's multi. But we will get to that by the end of the chapter because we cannot really avoid, well, we can, but sometimes it's like swimming against the current, avoiding reactive APIs in Quarkus because really the reactive core is so nicely exposed in some of the integrations like this streaming that it doesn't really make sense to use blocking APIs if you know that you are continuously consuming a stream. So let's stick to query and mutation. Query in GraphQL, it's just really HTTP GET. So you are just basically getting information. You shouldn't modify the data. Mutation is then really the operation which is intended to change the state of the data or update or create new. So my listing of cars is query, registering new cars and removing are mutations. Then basically everything that you will define inside the parameters or as return times, which are really a POJOs, like my car was here, only a POJO with public fields. Just remember that at least in my personal opinion, and I know that this is very debated, I believe that if you are creating a POJO with private fields and public getters and setters, which are just setting and returning the fields, then you can directly write them public because it doesn't really make sense. So this is why we opted in book to write less code. So here I have my car, I am returning car. Here I am returning list of cars. Everything is automatically parsed in the background. Oops. Come on, where did I go? Too far back. Sorry, I scrolled and I shouldn't have. So how we basically, like whatever you will like return from this method is up to you. This is nothing fancy. How you will actually use that and let me switch to 4.5 so I can actually show you that. Not one more. Let's do 4.5.4. So now I should have inventory service here, which I can open. And I will clean a little bit all the ideas and services because we don't need to that. So how will you call that is actually pretty easy. So now I will just show you the code in the IDE. So here is my model class car, and my service is this GraphQL inventory service. So as I was saying, GraphQL API, query, mutation, this is exactly the same code as you saw in the book. I'm just injecting car inventory, which is nothing fancy, just a step for a database, which is just creating some data. So we see something when we will be calling this service. There are multiple ways how you can call this now, but the easiest one is again DevUI, because DevUI is like very good for this kind of stuff. So you can see small I GraphQL, and something which I didn't mention. GraphQL is coming from this Quarkus small I GraphQL extension. In the DevUI, you will get this card which directly can show you the schema of your service. So here somewhere I should see my 2 mutations and my single query and the individual types of cars, because I'm also returning car and I'm using it as an input. I will get like a response car and I will get an input car, but we don't need to get into details. Like you can read this inside GraphQL specifications if that's something that you're interested in. What I want to show you is this GraphQL UI, which is actually GraphQL. And let me switch to, oh my God, okay. That's surprising to me. I thought that this will also change colors, but it doesn't matter. So inside here, basically you have an interactive client already configured to connect to your dev mode application running in dev mode. So now here I can directly start writing, let's say, query. I know that single query that I have and control space will actually give you auto completion is cars. If I run it like this, I will get only IDs. But because this is automatically connected. But what I can do here is to actually ask for different fields in my object, which is returned. And you see this is that actual solution for underfetching and overfetching. I am able from the client specify only the fields that I'm interested in. And if I don't specify them, they are not returned from the server. Actually, in the background, this is just HTTP. This is nothing fancy. It's just fancy HTTP, which will solve this issue for you in the background. So extremely useful. Again, if you want to do mutation, what was the name? Register ID. I think it was like this. Let me copy paste it from book to save some time. All of this is written here, so you don't need to remember this. So if I copy paste the mutation from the book because we want to save some time, boom. Hopefully it's valid. You will see that I am registering a new car, basically in this way. Okay, so I need to do car colon. Sorry, I forgot how to do this. I will specify my parameters, and then I will actually still I still have to specify the fields which are basically parsed from the returned car object from my service. So I specify that I'm interested in all of them, but I didn't have to. But if I now will try, and here is the history button, my query, again, I should see now 3 cars with the one that I just registered. Nothing fancy. This is extremely easy to use and pretty nicely configurable in Quarkus. So one other thing that I still need to show is how to do the client. And Smorai GraphQL is providing you with both the server and client APIs in the same extension. So if I want to just define the client GraphQL client API with this config key, which is actually also configurable in REST client, but it's basically just saying you like the configuration identifier that you are using when you are having multiple of these GraphQL clients. But you can see that it's exactly the same interface, which just extends inventory client, which is I forgot what. Oh, and I'm lying you because it's a separate extension, so a smaller GraphQL client. I forgot what this inventory client is. Oh. Oh, let's check. I don't need to guess. Which service was it in reservation? Come on. Let's just open it in IDEA. So I should have small RAI GraphQL client. That's good. And in my reservation availability inventory client occurs. So let me show you inventory client. So okay, this is nothing fancy. This is just our decision to define an interface for the client. So it's nothing fancy. But I should see here that like this GraphQL inventory client is actually only required to provide basically the Quarkus all the information that it needs. Again, interface with either add query or add mutation. Again, one-to-one mapping to how you would define the server. So basically, exactly the same thing. You will again inject it inside your application with GraphQL client annotation. Just you need to match the config key, which is intended for the client, and then the same type inventory client. Inside the configuration, now I should see smaller GraphQL client, and here you see that inventory, which is actually that key which you are configuring in the annotation, which needs to match. This is just required because you can have multiple clients connecting to different services. And you can see that this is connecting to 8083, which is my inventory service on /GraphQL. Other than that, exactly the same thing. So I don't think that I need to show it because I would need to run both services and I still want to finish gRPC. So if you have any questions, shout, but like you can try it out inside the book. I will move on now to gRPC because this is like really the synchronous protocols are extremely similar. There are like differences under the hood, which I will cover in the summary. But like from the user perspective, you are always just need the right annotation and probably just provide a bunch of interfaces or basically only implementation of the server side. Okay, let's move to gRPC because we really don't have that much time. So gRPC was basically created by Google because they wanted something fast. And gRPC is the only protocol from what we are showing here, which is actually able to do HTTP2, which also means that you can do multiplexing of requests and responses in one connection, which is extremely useful, especially when you are doing the same operations on top of like multiple different data. gRPC uses something which is called, well, it can use both binary and text protocols, but binary protocol is preferred because it's way faster. And to be honest, I haven't seen text like option enabled in any application that used gRPC so far. It uses a specification which is called protocol buffers. This is not specific to Java. This is really, I believe, CNCF project, which basically defined a new way of how to define a contract of your services. Nothing fancy. It's just a different DSL that you need to learn how to expose your operations. But you see that it's nothing fancy. You will just define the message in a very similar way as you did with GraphQL schema, which was generated there. You need to define this package, which is just like the package in which it will be like namespaced. But then you are defining a bunch of optional properties which are just used to actually specify how the code which will be generated from this protobuf file, which is usually .proto, will be structured. So you see that I want to use multiple files. It will be in org acme inventory model package, etc. You don't really need to deal with this at all as long as you are using Quarkus. So again, if you will add Quarkus gRPC extension, when you will run your build, during build time, Quarkus will find all of these proto files and they will run a tool which is called, I believe, protobuf, that will take this file and it will generate the Java classes for you that are basically providing interfaces and the model that is aligned with this proto file. So if I would run this build, and let me actually do that, in which section are we? Yeah, let's do the last one because I don't want to guess. So I will jump to the last section where we have everything implemented, and I will go to inventory service where we are having that file. Open it in IDEA. Let me close the other ones. So now in CRSM main, I have additional directory called proto, where I need to put my individual proto files. So I have only one, but you see that it's more or less exactly the same. We will just like skip through some of the things. So I will be probably need to like cycle back a little bit in one place, but let me run it in. Let me just run the package, and let's do minus the skip test to save some time. If I run the build, this is where I just want to showcase you the magic of that build time processing, because Quarkus is doing now Java execution code. You see here gRPC code gen in the background already during the build. When I will now check my target directory after the build, I should see here generated sources, gRPC, and inside here, it generated all of the Java source files based off that file. So if I take an example, let's do this remove method, because this is now already changed from 4.8.2 section. So this remove is taking remove car request, and you see the remove car request is just license plate number. I should see here remove car request, which is extremely complex. Surprisingly, it's a long time that I haven't opened this, but I see here somewhere that there is a license plate number field. You see it here, license plate number field, license plate number. So you have a bunch of these like different configurations, because this will generate builders out of the box, etc. We don't need to dive into that, but somewhere here I should have let's do mutiny inventory service, and somewhere here I should have remove. Yeah, here it is. So I have remove method which is returning uni, which is now like just deal with it, that this is out of the box mutiny, because there is somewhere here also default client which is generated by the protobuf tool, but as you can see, this is using custom classes from the gRPC Java client, which is possible to use, but it's not controlled by Quarkus. So this is why we opted in this chapter to use this mutiny inventory service gRPC, which is only generated by Quarkus extension, but it already uses small mutiny reactive times. Go ahead, Matheus.
It's a question about the why inventory service has mutiny prefix and mutiny code inside.
Yeah, this is what I was just saying right now,
Yeah,
because
yeah.
out of the box inventory, like the gRPC Java client will just generate this exact class. But as you can see, this is using IO gRPC method descriptor, Method descriptor, blah 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 blah, IOGRPC stub, abstract stub, etc. So these are classes which are not controlled by Quarkus, and they are blocking by default. So also the clients which are used in the background are not controlled by Quarkus. This is why Quarkus extension will add this mutiny version of the inventory service gRPC, like any gRPC service that you would define. Because basically now this is the class that we are controlling, and we can plug that vertex client in the background. We can like do all the stuff that we need to do. And also, if you are using mutiny classes, because if you will run into mutiny in one way or another somewhere in your applications, sooner or later you will basically learn smaller mutiny for sure when you are like deep diving into Quarkus. You will see that this extremely nicely plugs into the gRPC model. So this is why we opted to use mutiny already here, also inside the book, because just like explaining you the default client would be just waste of time, because it's also not the recommended way how we like the gRPC maintainers intended to use gRPC in Quarkus. So this is why we are sticked with uni and multi, but you will see this very nicely inside the book. So now I can take these classes, because they are normally generated Java classes, which I can, like, I will show you a trick which I'm using in IDEA. Just mark the directory as generated sources, and then your Java classes will know that they exist. Then, if I want to use them, all I need to do is again a class, which is, this is why we have inventory service, because we have now two services, GraphQL and gRPC, implementing the same service. I will remember eventually everything. So gRPC service annotation, again, very similar. And then you need to override, and this will be now inventory service. Okay, so that was probably the original intention, but now this inventory service is actually inventory service which is generated, so I was wrong. So this inventory service interface is generated by the gRPC extension from the protobuf file, and you can see that now it's returning uni or multi from smaller mutiny. But other than that, it's using the generated classes for responses and for requests. All I need to do inside my service is to override those methods. And you can see that multi and uni really nicely plugs into the model, because something which is actually the full chapter 4.8.2 or 8.1 is about is how to change the streaming in gRPC, because I didn't explain that yet, to something which is not only single response, but potentially unlimited number of requests and responses. And with multi and uni, this is extremely easy. So let's now just focus on this remove method, which is single result. Either single result or error. This is what uni is. So you can see that this both of these car requests and car responses are generated automatically with some builders. So we can skip this, because this is just finding the car in our inventory. But if we will find it, you can see that then I can extremely nicely create. This is how you will create uni create from some item. But the important part is this: car response, new builder, and basically a bunch of setters in a builder pattern, which are generated by that extension just based on the actual file from the protobuf. If I would be looking very hard, I will find it somewhere here, car response or builder probably. But you see that IDEA is automatically clever enough that it knows that this is using a protobuf in the background. So if I will go to this new builder, it will take me to protobuf, because this is really one-to-one mapping. And you know that whatever you will say in the protobuf will be always generated inside that builders, which are generated by the gRPC extension in the background. Extremely easy to use. From your perspective, protofile, and you are done. Okay, so let's move for a little bit back to the book, because I'm not sure if we are calling that out. I can probably show you how we are calling that. Again, the easiest way how to call it, if I run it again in dev mode, is to use dev UI, because dev UI is very nice for this client stuff. So, come on. If I now open a dev UI again, it opened in the wrong, but we can just refresh this one. That's okay. So somewhere here we should have gRPC, and you can see that I have one clickable field called services, which hopefully will find my services. Not sure what is happening now. Okay. Sometimes it will just, like, browser will keep some cache. But you can see, like, this health is not important. We have our inventory service here, and I can see the individual operations which I have defined in the proto file. And if I click this magic arrow, which is extremely hidden in my opinion, and we should change that, we can see, like, that we can actually invoke these operations directly in our application. So again, I will be not doing this because I would need to check the actual license plate number which we are creating there, but you can send the request and you are done. The last thing that we are doing in this chapter, and which we will be doing today, is actually implementing the gRPC client. And because this is, like, kind of out of our use case in our application, because we don't really need to have two different interfaces exposed in inventory service, we decided that you can see it here how it's being invoked, and you can see that if I send the request, I will get back the response. You will believe me. But you will see that for the first iteration of this service, where is the protobuf file? Protobuf, where are you? Here it is. You will see that even come on, I'm losing my mind. Remove car request, inventory service. Yeah, you will see here that the actual adding of car is also unary operation in this first iteration, not in the section that I checked out, but this is why actually here you see add is also returning uni. So we will start with a single use case, unary, one request, one response back. But this is why you see here add unary, remove unary. But in my application, you will see that add is now BD streaming. And this is the last thing that I want to do today. So this is what I want to show in this using RPC client with Quarkus. So because we opted to expose both GraphQL and gRPC as an inventory server API, we decided that reservation will call the GraphQL API, and for the gRPC, we will create a standalone CLI application, which will be intended as used by administration to basically do any out of bounds requests to or changes to inventory if there is a need. So we created a command line application that can change the directory through gRPC. So because we wanted to showcase something a little more complex, we decided that basically the application that we of adding the car will allow these multiple additions of the cars at the same time. So we will be using that multiplexing inside the single connection. And this is easily done in Quarkus because or in protobuf in general, because all you need to do is in your proto file add this magic stream keyword to either the request or to the response. And this is optional. You can choose where you will add this stream keyword, and then you will get these 4 different use cases for the gRPC client or client server streaming. Either it's unary, when you have only single request, single response. Server streaming, when the server is returning multiple responses, so single request, multiple responses. client streaming, multiple requests, single response, or bidirectional streaming, multiple requests, multiple responses. And you are controlling that by this stream keyword, whether you will put it to the request or the responses. So here we changed basically the unary add operation to bidirectional streaming by adding these two stream keywords at both request and response. So now this is why when you will see my client, you will see here BD streaming, and I will actually run this example. I probably will not. This is not bidirectional streaming. This is just multiple requests which are stacking the responses. But where is it? Oh, come on. I don't have the example. Okay, that is bad. So I need to come up with something that is very bad. So let me do very, very interesting. So if I now do BD streaming, if I send the request, you will see that the connection is kept open, and I can continue sending requests, and you will see that they are still stuck inside a single response until I will basically say this disconnect. If I would check actually if the cars are added, and let me actually do that, so you will believe me. Oh, what did I do? Okay, I have no idea what just happened. I already added the cars. Okay, but you will believe me that it happened at the same time, because until I will close the connection, the requests which I'm sending through that client are stacked in that stream, and then everything is sent at the same time to the server, and server returns multiple responses back. And it's very hard to showcase dynamically, at least if I have only one screen. So client extension, again, we are just creating a new that inventory CLI extension, adding gRPC extension. So this is where gRPC server and client are at the same extension. So I was knowing this one you need to configure. So if I would check inventory CLI, this one needs to actually have the connection configured. Again, inventory is used as a key, so you need to configure host and port on which you are running, but the individual proto file looks exactly the same. Here we are just opted to use still the unary version of the application. So you see that client doesn't need to have the exactly same one-to-one proto file to the server as long as it is compatible, basically. And if I will check where I have my, of course, this is now red because I need to run build in my application to get actually the generated gRPC stubs if I want to use them. Then if you want to use it, basically add gRPC client again with the key, exactly again the same thing all over again, and this inventory service will be the generated stub from the gRPC class. And once this is finished, hopefully here should be target. Let me do the magic trick. And now we should see that this is exactly the same interface which we implemented on the server side. And then basically you can directly call it exactly in the same way. Add, and you are using exactly the same builder patterns which are generated from the protobuf. Here, probably the last thing that I want to showcase is that we are creating a command line application. So this is how you can create a command line application. You will put add Quarkus main, and you will extend Quarkus application. And then you need to override one of these run methods, which are taking really the command line arguments. So you can see that if I run add or remove, then it will basically add or remove cars. And this is the last thing that we will do today, because I should have an example here, and I do. So I can run this command line. Oops. Because I compiled the application, java -jar normal Quarkus run jar. and everything after that is added as a normal command line arguments that you are passing to your application. So if I run it, we should see that I added new car. And let me do last magic tricks. So now basically this is everything that I wanted to show you today, and now it's time for questions. But in the last minute, I want to just show you how easy it is to compile it to native, and I really will get a command line application, of course. Sorry, because I don't have GraalVM installed for JDK21, so which I switched to. So I need to run that build inside the Docker container. We talked about this on session 2, I believe, but you will see now that because I don't have the GraalVM for JDK21, I ran it with, it's extremely small, but it's configuration Quarkus native container built through. And this is why it now goes ahead and downloads Mandrel, which is our distribution of GraalVM that we are doing now in IBM. And it will run my native build inside that container. As long as you are running Linux, this will run on your local machine too, which is lucky for me. But if you are on any different operating system, then you need to basically that you can run on your system. Okay, that's extremely slow. Okay, any questions?
One question about the CLI the application that simulates the CLI. Are you sending a gRPC request or not?
Yes, yes,
Could
this
you?
is gRPC.
Yes. Okay.
Yeah,
This is the
this
CLI.
is this. Yeah, this is, well, now I didn't implement the client because the
Okay.
client is actually generated by the protobuf. This is exactly the same interface as I'm implementing on the server side. I am just reusing it on the client side too. So everything, like this is why gRPC, as I was saying, is basically all about that protobuf, because all of the Java classes or Java code is then generated for you in the background. So all I needed to do is add gRPC client with the key, config key, and inside my configuration, I needed to configure host and port, and I'm done. And this is
Great.
already running gRPC in the background. So finally, I'm running the build in the background. So any other questions? Then if not, we can wait for my native, which is extremely slow because, of course, when you are live streaming, my CPU is at 98%. Very nice. But it should be finished fairly soon. I just want to really show you that, like, as long as you are using Quarkus extensions, all you need to do to run native build is -p native or -d native, and it will always work. Now, that, of course, it can be like a little bit like of configuration issues, but like most of the time, you are good to go. Oh, come on. This is extremely slow. But we are more or less at the end of chapter 4. And don't worry, this was one of the longest ones. There is also chapter 9, which is similarly long, but other than that, we are done. So I have my native, and now all I need to do is change java -jar to target / my Quarkus CLI runner, and I'm doing exactly the same thing, just with CLI. And I really have a command line application, which you can see is starting somewhere in 12 milliseconds.
Oh,
So
nice.
now with that, I am done for today. Okay, thank you.
Thanks a
So we
lot,
are done with
Martin.
chapter 4.
João, do you want to make some question? What is the minimum computational power required to run native image?
Well, when you already have the native image, is extremely like lightweight, like extremely low on memory, and like computational power depends on what you are doing in the native. But what is hard on your system is that actual build, because you probably, oh, well, maybe you were able to check that or not, but you will see that peak RSS was 2.48 gigs. CPU load 10% of my, like all of my computational power was just taken for this very small application. So it's hard, let's put it this way, to compile the native. But when it is compiled, you are more or less like, it's extremely lightweight, extremely, but static, as we talked about. So
Great, great,
hopefully that
great,
answered the questions.
great question, Joel. Uh, okay, I think you have more questions, Joel, or not?
No, no. You
Okay.
finished.
Thanks a lot, Joel and Dennis, Victor, and again Martin, to this great chapter. And let's do the next in the next week, the chapter 5. And bye bye. Uh, See you next.
Bye, guys.
Thanks.
See you.
Bye bye.
Bye.